welcome back to my channel. Bing. Just kidding. Hi fam. These are our solutions for lesson 75. This one was kind of a doozy, but very interesting in my opinion. We have two problems for the check 4 understanding. One of them is a big old long free response, and then the other one is a multiple choice. So I imagine that one of the hardest parts about completing this problem was deciding what your alternative hypothesis would be. So I'll walk you through what I did and then give you an idea about what would be acceptable that's different from what I have. So we are testing whether or not sense will improve performance, essentially. So we have our participants, our subjects, wear a mask that's scented and wear a mask that's unscented. So they end up wearing both masks, and the order in which they wear their masks is randomly chosen. The thing that we're testing, what we think is going to happen, is that these people will be able to complete the maze faster when they have the scented mask on. So I had to write this out just so that I could wrap my mind around what they were telling me. So we think that the scent helps. So scented masks, or the scented mask time, are expected to result in shorter or smaller times to finish the maze. So we think that the scent helps. So the scented masks are expected to result in shorter time, which means that if I take my scented mask time and subtract my unscented time, we'll get a negative difference, because we think that these values of S are going to be smaller than these values of U. So the other thing that I knew that I would need to pull is my sample statistics, and I knew that I was going to need to graph the sample data. To do that, I decided to enter in both of these lists. So one way you could get the differences is if you go to your list, you can see in mine that I have the unscented values in list 5, and I have the scented values in list 6. So instead of going through and subtracting all of those numbers, for list 4, what I did was I told it to take the scented list and subtract the unscented list. So to do that, you would highlight the list that you want to put this in. So these are the two that have our exact data, and now I have a third one that I'm going to use my calculator to find the difference. So I would hit blue button 6, and notice now it says list 6, subtract blue button 5. So this is now my scented, subtract my unscented. And what you can see here is a list of the differences. So now I don't even have to write those differences down because I have them in my calculator list. So then I calculated or found my one variable stats. So I had to go to stat, calc 1, and then list 4, because that's the list my differences are in. If we did that correctly, then our average difference is 0.95. So that does mean that for this sample, on average, the scented mask did improve the time, or did improve your performance and make it so the time to complete the maze was a little bit faster. Standard deviation, and I noted my degrees of freedom here. here is the box plot of my data. If you looked at the histogram, it's almost exactly symmetric. So this is a really good data set. So if you go in and just check, which I'll do for us, if I check my box plot, got to change to list 4. If you can't see yours, remember it's zoom stat. So that's the one that I have. Yeah, mine looks a little different than that. Let me investigate that real quick. Okay, I adjusted mine, so it's a good thing I decided to actually plot this in my calculator. My value, my median, was on the wrong side. The median is positive 8.7, and I had it graphed at negative 8.7. So he's roughly symmetric. If I check my histogram, not that we normally do that, but in case we wanted to. On histogram. I'm not sure why it won't graph that for me. Clear. I wonder if it's because it has negatives. Let me check that now too. Okay, I figured it out. Sorry I had to do that twice. So if I go in and graph the histogram actually looks really nice. If I change the window to maybe an X scale of 10, look at how symmetric that is. That's almost exactly symmetric. And then the last one that we might want to look at is the NPP. So if I graph that, that's pretty linear. So based on those 3 graphs, I think that we're totally good to do a T procedure. The only one that I graphed was the box plot because it's the fastest. So here, make sure that you labeled your axis, your x-axis, and explicitly stated what the difference is. So scented subtract unscented, which reminds me, you could have done this the other way around. You could have done unscented subtract scented and still got the same conclusion. So if you did that, don't go through and erase, because by the time we get to the bottom, our numbers will be similar and our conclusion will be exactly the same. So keep it the way that you have it. Okay, so for our state, you guys can read mine. Your alternative, though, it matches what I have here. If we're doing S subtract U, then this should result in a negative difference. So because of that, my alternative is a less than. So negative numbers are less than 0. So the reason I have a less than here is because if the scent is effective, those numbers will be smaller, which would result in a negative. If you decided to do U subtract S, what you should have here is the opposite. So your mu sub D would be greater than 0, because your U numbers will be bigger than your S numbers. I clearly define my mu sub D and state the direction of my difference, which mine is backwards, so I need to fix that. Then we're doing a 1 sample paired t-test for mu sub D. That makes us sound like geniuses. Make sure that you wrote that in. I checked all my conditions and it was very similar to the first problem we did together. So researchers randomly selected the order that they assigned the mask the participants wear. N is less than 30, but a box plot of the sample data is approximately symmetric with no outliers, so it is reasonable to use a T procedure. Notice that I wrote in here what about the box plot makes it okay for us to use a T procedure. So you either have to write it here or you have to write it on the graph and then say C graph. I didn't mention anything about the 10% condition because we don't need to check it. You only need to check 10% condition when you are sampling, and we're not. This is an experiment. This is the T critical that I get with my sample data. Now, if you used U minus S, your T critical is positive, not negative, and it's the same value. So if you did yours backward of mine, you should have positive 349 here. This number is so small that it's not even on our pink table. So if I go to our pink table, degrees of freedom 20, and I try to find a T critical of 0.3, it's somewhere over here, which means that your p-value will be greater than 25%. When you use your calculator to get the actual value, it's 36%, which is definitely bigger than alpha. So we fail to reject the null. We do not have convincing evidence that the floral scent improved performance on average. So here it says, do these data provide convincing evidence that the floral scent improved performance? And that's why I framed my answer the way that I did. You could also say we do not have convincing evidence that the difference in time it takes to complete the maze is less than 0. Either way, it has to be framed around the alternative and not the null. So you can say we do not have convincing evidence that the floral scent improved performance, or we do not have convincing evidence that the difference is less than 0. If yours is reverse of mine, then you would say we do not have convincing evidence that the difference is greater than 0. You can do either one because they're both true. If you do S subtract mu, you would get a negative number. If you do mu subtract S, you would get a positive number. So either one, either way you thought of this problem, you should end up with the same conclusion and the same p-value. Then on the last one, I find the easiest way to answer these multiple choice questions is just to go through and do the problem as if it were a free response and then compare what I have to my answer options. So this problem is about whether Friday the 13th has an effect on people's behavior. So fun fact, me and Man got married on Friday the 13th because I was a little scaredy cat growing up, and I used to be really superstitious, so it was Friday the 13th once, and I was talking to my dad about it, and he's like, oh, don't be scared. Friday 13th's good luck. Friday the 13th should be a good day. So, I don't know. Does Friday the 13th have an effect on people's behavior? So to check this, they look at grocery stores, and they're thinking that there will be more shoppers on the 6th than there are on Friday the 13th. So they're thinking, well, on Friday the 13th, I don't know, maybe people are staying in their houses and hiding because something bad might happen. So if that's the case, we think, if they think that Friday the 13th has an effect on people's behavior, then we think there will be more shoppers on the 6th. So what they want us to do is carry out a hypothesis test, and they're actually doing that the null is that there's no difference, and that the alternative is there is some difference. It doesn't indicate whether or not we think that it'll be less or more, which is okay. I'm thinking that this is what they are getting at here, but this is the test they're deciding to run, and then they want us to check the conditions. So the random condition is not met. They just took a sample of 45 nearby grocery stores, so that one's not met. And the 10% condition is not met because in order for the 10% condition to be met, there has to be 450 grocery stores nearby. If we think about Magna and West Valley, I think there's probably 10 grocery stores in 2 cities. So the idea that there's 450 grocery stores nearby, that's nope, it is not reasonable to assume 45 is less than a tenth of the population. But our sample size is big enough. It's greater than or equal to 30. So the only one that's met is the normal large counts condition, and really it's the large sample condition that's met. So this is C as in cat only. Okay, that's it. Hopefully you guys made it through this difference problem, because for some reason I just feel like if they're going to give you a hypothesis test on your exam, it's going to be one of these harder ones. So hopefully that went okay for you. I know that these differences can be hard to wrap your mind around, especially deciding whether or not you want to use a less than or a greater than or not equals to. So as I often say, you just do the best that you can, and that's all you can do. So that's it. Love you guys.